In our quest to uncover lost chapters of Earth's history, myths and geological clues can only take us so far. To truly unlock the secrets buried beneath our feet, we must turn to the tools of the modern age. Technologies that can peer through jungles, beneath deserts, and into the very bones of our planet. Welcome to the era of high-tech archaeology. For centuries, excavation was the gold standard of discovery. But today, satellite imaging, LiDAR scanning, ground-penetrating radar, and isotope analysis are reshaping how we understand ancient Earth. These tools are capable of detecting structures that the eye, and even conventional excavation, would miss entirely. Let's start with LiDAR, or light detection and ranging. This laser-based scanning system can map the ground in astonishing detail, even beneath dense forest canopies. It's already rewritten history in parts of Central America, revealing massive ancient cities and road networks hidden beneath the trees. Entire civilizations that were previously unknown. What else might LiDAR discover? Some researchers are now using it in the Amazon, the Congo, and other remote areas, searching not just for lost human civilizations, but for geometric anomalies, patterns in the landscape that defy natural formation. Could these be the remnants of something older than we've dared to consider? Then there's deep ocean sonar, a technology that allows us to map the seafloor. Vast portions of Earth's oceans remain unexplored. Over 80% beneath the waves we've found strange geometric formations, ridges, and what some interpret as terraces or ancient breakwaters. While most of these can be explained geologically, a few remain unexplained. One of the most controversial examples is the Yonaguni Monument off the coast of Japan. This massive stone formation bears what appear to be steps, platforms, and right angles, features uncommon in natural formations. Some geologists insist it's a quirk of tectonic activity. Others argue it's the sunken ruin of an ancient city, lost when sea levels rose at the end of the last ice age. But suppose it's both. What if ancient peoples built atop natural formations? What if the origins go even deeper, to a civilization wiped out long before the ice age ended? This brings us to another powerful tool: isotope dating, especially uranium-lead dating. This method allows scientists to determine the age of rocks and materials with extreme precision. It's been used to date the oldest materials on Earth, some over 4 billion years old. Imagine applying that kind of precision to a strange artifact or mineral anomaly found in a place it doesn't belong. If the age doesn't match the surrounding sediment, it could suggest displacement or something far more mysterious. The problem, however, isn't always in the data. Sometimes it's in the interpretation. Anomalous readings are often dismissed as errors, outliers, or contamination. But what if they aren't? What if they're evidence of technology or activity out of time? To spot such patterns, some researchers use AI and machine learning to scan enormous data sets, satellite images, magnetic anomaly maps, or seismic data. The AI isn't burdened with assumptions. It simply looks for patterns. Some of the findings have been surprising: repeating geometric structures, rectilinear outlines beneath the surface, or magnetic signatures consistent with metal masses, in places no modern construction has ever occurred. Skeptics argue these are coincidences. But in science, patterns demand investigation, especially when they repeat. Even our understanding of ancient artifacts has changed with technology. Spectroscopy, electron microscopy, and 3D scanning allow us to analyze tools, bones, and carvings at the molecular level. Microscopic tool marks, residue of synthetic chemicals, or even isotopic ratios in carvings could reveal far more than previously imagined. Take the example of OOPArts, out-of-place artifacts. From the Antikythera mechanism to strange metal spheres found in ancient strata, these objects defy conventional timelines. Most are explained as misidentifications, but a few remain genuinely puzzling, especially when their composition or design suggests advanced understanding of geometry, astronomy, or metallurgy. Could these be the remnants of a lost civilization? Or contact with one? Even if we've never found a complete ancient machine, absence of evidence is not evidence of absence. Over millions of years, nearly all structures would be destroyed, recycled by Earth itself. What we might find are only fingerprints on the stone, scars in the strata, and yet, it may be enough. As more data pours in, some scientists call for a new field of study, paleoarchaeotechnology, the investigation of deep-time technological signatures, combining geology, chemistry, archaeology, and artificial intelligence. The goal isn't to rewrite history with fantasy, but to test hypotheses once thought unthinkable. This is what the Silurian hypothesis proposes. Not that another species built the internet millions of years ago, but that if one had, we might not even know unless we look in just the right way. The question is no longer, did it happen? But would we even know if it had? On Infinity Beyond, we believe the future of archaeology lies not in digging deeper, but in thinking deeper. It's about recognizing that the Earth may be holding on to secrets, not because it wants to, but because we haven't yet learned how to read its language. In the next segment, we'll explore the ethical and philosophical implications of discovering a lost intelligent species. What would it mean for our identity, our future, and our place in the cosmos? Stay tuned, because the past might just be the key to understanding what lies beyond.